Hello everybody! Have you ever wondered how you can track objects in and around your house, such as, for example, your kids' toys, your kids' bikes, your kids' strollers, your kids' sleds or whatever, in order to make sure that, for example, at night, when it's getting cold and wet outside, when sneaky people are walking around your house, you can ensure that those objects will not be forgotten outside unattended? If yes, then this is the right video for you. Let's just jump right in.
Smart home maker, rock the beat. Innovation at your feet. Build it up, don't complicate. Home solutions, you're the mate.
So first of all, I would like to explain which options I see to attach something to your objects you want to track in order to track them within your house. Well, the first option I see are the Apple AirTags or comparable devices from other manufacturers. Those are really awesome little devices. They're really small and they allow you to track objects nearly anywhere in the world, and this works really great. But as those are usually manufacturer-based ecosystems, it is not so easy, like for example for the Apple AirTags, to integrate those with your smart home solutions such as Home Assistant. And this is really a pity. For the Apple AirTags, there is a possibility to integrate with Home Assistant. I have already made a video about this. A fellow smart home YouTuber, Flotomation, explained how to do it, but still it is rather complicated and also prone to error. Another downturn is that they have limited room-based tracking capability. I mean, what you can do with, for example, your AirTags, you can use your iPhone or other device from Apple to track this object within your house and also to navigate to that object. This works really well, but what is really difficult is to track in which actual area of your house this little AirTag, for example, is at the moment. And for our solution that we are going to build, which allows us to track objects in and around the house to identify whether they are, for example, placed in the garage or in the basement where they should be, this is not an ideal solution. And also the manufacturer-based ecosystems are usually rather expensive. Like the Apple AirTags, they are not that cheap. Another option I see for this use case are Bluetooth Low Energy beacons or BLE beacons. Those are also usually rather small devices that allow you to track them via Bluetooth. And with this, you can create your own tracking method within your house with your own hub or hubs. That means you can create a hub which tracks all the objects around, and you can place multiple of those hubs in and around your house, and this helps you to identify whether an object is closer to hub number 1 or hub number 2, and with this you can identify in which actual room of your house those beacons are at the moment. So this is more of an open solution, because there are many open source solutions out there which allow you to build up such hubs, and then you can also easily integrate with your own smart home solutions. Whatever it is, Home Assistant, IO Broker, or whatever you have for a smart home solution. Because usually those open source kind of hubs, they also integrate with standard technologies, such as, for example, MQTT, in order to be able to send the tracking information to your smart home. And this is really cool. And also a benefit of those BLE beacons is that those are usually rather cheap and you can buy lots of them in bigger packages. And so that's why I have decided to go with the BLE beacon approach for this project. Now we know which hardware to use to track our objects in and around the house. It's those little BLE beacons that we are going to use. But now we have to also decide on which technology we want to use or which software we want to use in order to track those hardware objects within the house. And that's what I'm going to explain now. The first option we have to track objects within your house is to simply use ESPHome. You can reuse an existing ESPHome node or create a new ESPHome node that you place in your garage or your basement or wherever you would like to track your objects. You just need a couple of lines of YAML code in the ESPHome YAML file to define which objects you want to track. This is super simple. It only takes a couple of minutes, maybe half an hour to create this, and you're done. But it comes with some downturns. The downturn is that if you would like to track multiple objects over multiple rooms in your house, it gets more complicated, because then you would have to implement the logic for identifying which node is closest to an object yourself. The second option we have is to use a solution like ESPresense. There are multiple of such solutions out there, but I'm just going to stick with ESPresense because that's the solution I use. ESPresense allows you to track multiple objects over multiple rooms. And this is done by placing distinct ESP32 nodes, which are flashed with ESPresense, in multiple rooms of your house. For example, you can place 1 or 2 nodes per room in your whole house, and with this you can track the objects within your whole house. The problem with ESPresense is that it really requires distinct ESP32 nodes. So that means you cannot reuse those nodes for other things. That's not completely true, because for example ESPresense allows you to also attach certain sensors to these ESP32 devices and then also report their values to your smart home, but this is a limited approach. It's not as flexible as ESPHome, for example. And with ESPresense you have a really reliable and good solution that allows you to track the objects over multiple rooms, and it is compatible with different smart home solutions, such as for example Home Assistant, but also other smart home solutions, because for communication with the smart home it just uses the standard MQTT technology, which is actually compatible with probably most of the open smart home solutions that are out there. The third option I would like to explain is Bermuda BLE. Bermuda BLE works pretty much the same as ESPresense, but the cool thing about Bermuda BLE is that it does not require you to add new distinct ESP32 nodes to track your objects within your house, but you can reuse the existing Bluetooth proxies from Home Assistant. So if you have already some ESPHome nodes in your house that you have marked as Bluetooth proxy, or some Shellys, which is also cool, that work as a Bluetooth proxy. And I mean, if you have Shellys installed in your wall in different rooms, and you can just reuse them for object tracking, this is awesome because it does not require you any new installation, and they are also kind of invisible. And it is natively integrated with Home Assistant, so it comes as a Home Assistant integration. And it even reuses the concept of areas in Home Assistant, which was introduced, I think, a couple of months or a year ago. So that means if you attach an area to a Bluetooth proxy, for example, kitchen, and the object is close to that proxy, it will be automatically marked as in the kitchen area. So this is really awesome. And really easy to set up if you have already some Bluetooth proxies in Home Assistant, but it also is, for the time being, I think only compatible with Home Assistant as of this. I for myself decided to go for ESPresense for this project. The reason is that I have tried out Bermuda BLE and I was not so persuaded about the results, or let's say it like this, the results with ESPresense were better, and I have already placed multiple ESPresense nodes in my house. So for me, it's not a big deal to go with ESPresense, but for you it might be really easier to go with Bermuda BLE. And maybe I have also configured Bermuda BLE wrongly, so I don't want to say that Bermuda BLE is worse than ESPresense. Maybe it's even better and it has a lot of advantages. So maybe for you it's also good to go with Bermuda BLE. I will briefly explain all of the 3 methods in the upcoming video part. Let's start with ESPHome BLE tracking. First thing I would like to explain is how you can add the ESP32 BLE tracking to an existing ESPHome node. So in my case I have this car sensor garage door, This is actually an ESPHome node used for tracking whether there is a car in front of my garage, and if there is a car in front of my garage, I will not open or close the garage, or will not allow to open or close the garage door remotely in order not to damage the car. There is a video I would link above which explains actually how to create such a sensor. It's an ultrasonic sensor. But this is not the scope of this video here. In this video I would like to explain how you can just use any existing ESP32 ESPHome node in order to use it for BLE tracking. So you just have to add this line of code ESP32 BLE tracker, and then we can create some binary sensors of platform ESPresense, which track whether the MAC address, and this is the MAC address of your BLE beacon. If you don't know the MAC address of your BLE beacon, you can just use any app. There's a lot of apps out there in the App Store which you can download to your smartphone, and you can scan for nearby BLE beacons, and then you can read out the MAC addresses of those BLE beacons. So with this you can check whether this MAC address BLE beacon is actually present. And you give it a name, ESPresense kids bike, for example. This means this is a beacon that is attached to the bike of my little daughter. You can define a timeout, so if it's not visible for more than 1 minute, it will definitely be qualified as not present. And then you can also define a min RSSI value, so that means if it is further away than a certain distance, so that means if the received signal strength is below this threshold here, it means that this is also not present. So with this we have just a simple binary sensor that says present or not, and I have defined 3 of those for 3 different beacons. But I have also created some BLE RSSI sensors because I would like to also be able to read out the raw RSSI value, so the raw received signal strength of those 3 beacons. That's it. You don't need more. And if you then flash this to your ESPHome node, you will be already able to read out the data, and I can show you how this looks in Home Assistant now. So this is how it looks in Home Assistant. You can see our sensors. Yeah, there is the distance to the car. Okay, that makes sense because my car is at the moment standing in front of the garage. So that is correct, but that's not the actually scope of this video. We have our presence sensors. So that says ESPresense kids bike, ESPresense kids motorcycle, ESPresense kids stroller. So the motorcycle and the stroller are in the garage, that's correct. And the kids bike is actually not in the garage because this beacon is currently still on my desk. So that's also correct, so in my desk in the office. And that's why it also cannot read out the RSSI value of this BLE beacon on my desk because it's too far away. But the motorcycle and the stroller are in the garage and they are close enough so that it can read out those RSSI values. And you can see that this works great. I can directly see that my kids bike is currently not in the garage, which is correct, and I can see that the motorcycle and the stroller are in the garage, and I can even use the RSSI value to do some further calculations. For example, if I would like to identify how far away they are from this node. So super simple solution, and this gives me everything I need in order to identify whether my devices are available in a certain area or not. Second solution I would like to briefly explain is Bermuda BLE. Also for Bermuda BLE I don't want to go into too much detail. But what you have to do is you have to install the Bermuda BLE integration in Home Assistant, and once it's installed you can open it up, and then you have to go to configure it. And what you can see here is that you can see some of the active devices which are my Bluetooth proxies in the house. So you can see that there is already quite some amount of Bluetooth proxies in my house which can be used for Bermuda BLE. It also says it can currently see 29 active out of 295 Bluetooth devices. and it can see 7 active out of 7 Bluetooth scanner devices, which are the Bluetooth proxies. So you can see that it automatically recognizes those Bluetooth proxies in my Home Assistant installation and can use them as scanners, which is nodes that can actually identify whether an object is close by or not. There are some global options that you can adjust for Bermuda BLE, and maybe this is something I was doing not perfectly because, as I said, I'm not perfectly convinced with the results of Bermuda BLE. And also what you can do is you can select your devices. If you click this, you can see that I have selected some specific BLE beacon devices. Those are some of my BLE beacons that should be tracked with Bermuda BLE. I can open this Configured Devices tab or a drop down, and you can see that there is a lot of devices that are recognized, and then you have to just look for your specific devices. For example, I think this one here is also one of the beacons that I could just add here, submit, and then finished. And now you can see it has updated. There is now 7 devices, and I can just select. I have already configured those here: kids bike, kids motorcycle, and kids stroller. If I just click on, for example, kids motorcycle, you can see that there are some informations displayed here. I can see the area, so it currently displays it as in the garage, which is correct actually. It says there is a distance of 0.9 meters. The nearest scanner is the car sensor garage door, which is also correct. This is my ultrasonic car sensor ESPHome node, which is also qualified as a Bluetooth proxy. It gives me also the nearest RSSI value, which is the RSSI value to this scanner here. So it looks quite okay. But my problem is that the area is constantly changing. And I'm having a ESPresense node also in the garage at nearly the same position than this ESPHome node car sensor garage door, and for that node it's really stable. The area is always garage, and here the area is switching to different Bluetooth proxies in my house. Maybe it's because of the position of those Bluetooth sensors proxies. They're maybe not perfect, but yeah, anyways, I'm myself not 100% persuaded, but still I think the concept of Bermuda BLE and using the Bluetooth proxies in your house that are already installed is really awesome. And if it works well, I think it's the best solution you can find. But now let's go into detail about how to set up ESPresense. Installing ESPresense on one or multiple ESP32 dev boards is quite simple. You just go to ESPresense.com, then you navigate to Base Stations, Nodes, click on Install Firmware. Now you can see there is a browser-based installer, which makes it super simple to install it. You just have to connect your ESP32 dev board via USB to your computer. I'll do that now. Then you have to click Connect. And you have to select an according connection to the device. And now it says connecting. You say install ESPresense, erase device. Next. You want to install? Yes. So now the installation is being prepared. And you might have to press the boot button on your device in order to bring the device into the bootloader mode so that it will be able to install the firmware. Now you can see it's erasing and installing. As this will take a little while, we will speed it up. Perfect, we can now see that the installation was complete. Now we click Next, and the next step you have to do is to configure your Wi-Fi credentials. Then we click Connect. So now this tells you there would have been a timeout. And this looks like as if there was a problem with sending the Wi-Fi credentials to the ESPresense device, but actually, in most cases that I have experienced in the past, it still always worked. So you can go into your router settings and search for a device with the name ESPresense dash and then some cryptic name, and then you should be able to find a new device that has connected to your router. And in my case, as you can see here, that's the name of the device, ESPresense-C09FCD. This is just a random name that is provided by ESPresense for such a new device. And now we are already at the configuration page, which we can use to configure our ESPresense device. First thing we have to set up is the room name. That's very important because that is going to be the name which the devices will be assigned to when they are close to this node. So that means in my case this is garage, because I want to monitor the devices in the garage. So I'm going to give it the name garage. And then in Home Assistant later on, whenever the object is in the garage, it will have the name garage, which means it is in the garage. I think this is great. And then there is further configuration you have to carry out. Important is MQTT. So if you use, for example, Mosquito as an add-on to Home Assistant, you can usually just type in your Home Assistant server. So in this case, Home Assistant.local, for example. If you use the actual name, then it will also resolve the IP address later on in case your IP address of Home Assistant will have changed. So that's why I use Home Assistant.local. And then the port should normally be 1883. This is the normal MQTT port. So in case there is anything different for your configuration, you have to, of course, adjust it accordingly. And then you have to give your username and password. Once you have done that, you have some options here. Send to discovery topic, that's default, that makes sense. Send to telemetry topic, makes sense. Send to rooms topic, that is something deprecated and therefore you don't need it anymore. It was some thing in the past. But send to devices topic, this is the most important thing because this is where it will send the device information to this topic. So that means it will send for each device that has been recognized in vicinity of the ESPresense node, it will send a message to this MQTT topic devices, including the device name and the distance, for example, to the ESPresense node. Then you can, of course, configure some settings about the updating of the device, etc. You can decide whether you want to have some automatic updates or you rather want to update the nodes manually when there is a new ESPresense version available. To apply the changes, you have to click Save and then Restart Device. So now you see it says Bye and it will restart the ESPresense device. Once the restart is done, you can open the device again. But if you use a Fritzbox, for example, and you use this device name to open the device, then there is the need to change the name now, because the name is now ESPresense-garage, because we have changed the room name, and then .fritzbox or any other router information. But you can of course also use the IP address of the ESPresense device to access this page. Now we have configured everything in this page, but we have to go to the other settings, and this is, for example, can be opened by clicking this link. But generally you can also just open this page by opening IP address or this URL /UI. Yeah? And then it will automatically open this more beautiful page where you can have some additional settings. And here you can type in some additional information for scanning, for querying, for counting, for filtering, for calibration. And you also have the possibility to connect further devices to the ESP ESP32, so you can actually use your ESP32 for additional use cases. For example, you can attach some LEDs, you can use the GPIOs for adding some PIR motion sensor, some radar, whatever, switches, buttons, etc. This can be forwarded via MQTT as well. So you can actually use your ESPresense device as a sensor or any other use cases you can imagine, which are supported by the different fields here. So you can even connect some I2C buses or sensors, etc. So you see there's some possibilities to reuse these devices also for other use cases, for example as an air quality sensor additionally, or etc. So that it's not only placed somewhere for only reading out information about devices in vicinity, but also for using it as a sensor. But I don't use that at the moment. So my notes are specifically for ESPresense. So what you can do now, that's very, very cool. You can go to fingerprints, and now it's going to load the fingerprints. And what you can see here is all the devices that are currently being detected by ESPresense in my in the vicinity of this node. So this is awesome. As you can see, there's so many devices that it recognizes, and you can use all of those or many of those for automations, etc., whatever you like. What's very interesting for our use case here are these beacons that I want to use. And what you can see here is that we have 3 of those beacons. You can see, you can identify them by their ID, which is iBeacon, and then a certain kind of random name, a certain address or whatever. And this is unfortunately always the same for all of those beacons from this manufacturer, as you can see. And they all are lying close to each other. And if I take one of those now and put it more away, you should also see that the distance increases. You see, this is this one here. So now it's already 1.7 meter away, even a little farther now, 2 meters. And now I bring it back to the other 3, and you will see that it goes down again. Yeah. See, now it's they're all together again, and this is really cool. So you see how great this works, and how responsive it is also to changes in the environment. And here you can also see some devices like my iPhone. This is an iPhone, or this is a device that needs to be enrolled, because iPhones change their MAC address randomly and regularly, so it's not that easy to track them. That's why you need a specific enrollment procedure. It is described in the ESPresense page in detail. So once you have enrolled the device, it will also always be recognized, and you can use your iPhone to track yourself, kind of where you are in the house. And depending on this, you can, for example, turn on certain lights or do whatever you want in terms of automations. But that's not the main scope of this video. The main scope of this video is tracking those beacons. And what you can see here is, as I said, all these have the same address. So we need to find a different way to identify each individual beacon, and that's the MAC address. You can see the MAC address here. These are the MAC addresses, so they are different. What we have to consider is that ESPresense by default will just send the ID of the device to Home Assistant. So only by the ID we could not differentiate between the 3. That's why we need to copy the MAC address of those devices. Copy. And then we go to settings and we put it here to known MAC addresses. So these are all the MAC addresses of the 3 beacons. And I just put it here, save, and then restart. And now the cool thing is that ESPresense now knows these specific MAC addresses and monitors those 3 MAC addresses and will send them separately as a specific identifiable device to Home Assistant via MQTT or to your MQTT broker actually, and from there Home Assistant can read it out, and this is really great. So with this we are now able to identify each individual beacon in Home Assistant, and I'll show you how this works. Now I want to show you how you can get your BLE beacons to Home Assistant. For this you have to open your configuration.yaml, and then below the sensor node we have to add some additional sensors. And each sensor is of platform MQTT room, and then we have to give it the device ID, which is, this is important, known, colon, and then the MAC address. And this is specific to those devices that you have added to the input field known MAC addresses. So you have to add your MAC address to this input field that I have shown you before. Otherwise it will not be forwarded as a known device, and so you will not be able to use this, and this will not work. Then you have to give it a state topic, and the state topic is ESPresense/devices/known colon and then again the MAC address. So this is the same than the device ID. Then you can give it a name. In my case I named it Kids Bike Green, which is actually the bike of my daughter. You give it a timeout of 5 seconds in this case, and then a wait timeout of 60 seconds. So that means if the device is not recognized for 60 seconds, then it will be definitely marked as away. So the device is not present anymore. And then the same thing for all of the other devices, my kids motorcycle BMW, my kids jogger blue, and my kids stroller gray, for example. Those are just 4 example devices, but I will add more in the future. And that's it. Now you have to save this and restart Home Assistant. And afterwards you will be able to see your devices as new sensors in Home Assistant. And now I have this awesome little dashboard here in Home Assistant that tells me exactly where all of my objects are. I have some of the objects that are coming from the iCloud integration, like my iPhone, my Apple Watch and my MacBook Air. I have the Skoda integration, or the actually Volkswagen integration for my car. And then I have some of the objects coming from the Find My network from Apple, the wallet, the laptop bag, the carry-on luggage and also my keychain. There is a great video made by Flotomation, a fellow smart home YouTuber, who explained in detail how you can sync the Find My network from Apple with Home Assistant, and I will link this video in the video description, but this is also not the scope of this video here. And then I have my additional new objects which are identified via the BLE beacons, which is this Kids Bike Green, the Kids Motorcycle BMW, the Kids Stroller Gray and the Kids Jogger Blue. Those are just 4 exemplary objects. I will add more of those objects in Home Assistant, but you can see that this Kids Bike Green, it's actually, the beacon is still on my desk here, so that's why it's correct that it says Keller. Keller means basement, and this is where my office is. We have the Kids Motorcycle BMW and the Kids Jogger Blue, those are both in the garage, and that's correct. And we have this Kids Stroller Gray, and it says Erdgeschoss Eingang Küche, that means actually entrance area of the house and kitchen area. And that's also true because this Kids Stroller, yesterday in the evening we left it in the entrance area of the house and not in the garage as it is usual. So this is also correct. Okay, now we know how we can track our beacons in and around the house. But how do we actually attach those beacons to our objects? For some objects it's quite simple. For example, for the strollers of my kids. They usually have some little bags where you can just drop the beacon in, like you can see in this video here. So that's quite simple, but how do we attach it to objects like this kid's motorcycle here or this kid's bike here? That's not that easy, but for this I have also found a solution. For example, for this kid's motorcycle here, I realized that it makes sense to open up the front part of the steering bar handle, because this includes the electronics for playing some music and it also includes the electronics for the lights. And I realized that in this area where the electronics are stored safely in a waterproof housing, there is still some space left. So I just glued the little beacon with some double-sided tape into this compartment, and then I closed up everything again. So now I have this beacon inside the motorbike, and it can never fall off or something like that, and I have secured it in place. For the kids' bicycle, the problem is that there is no enclosed compartment where I would be able to drop or glue in this beacon. And also there is the problem that those beacons, the housings of those, they're really like flat, they don't have any holes where you can just attach something. It's really difficult to attach those to the bicycle, and I needed to attach it somewhere to the bicycle frame. My idea was to attach it below the seat, and for this I designed a little addition to this tag, and you can see it here. It's like a little handle where you have also a hole where you can just attach it somewhere. And this is some part that I really designed myself in CAD, and then I printed it on my 3D printer, as you can see here. So with this little addition to the beacon, we can now attach the beacon wherever we want. And I think this is really helpful, and I will also place the link to this file in the video description or in the corresponding blog article, so that you can download it and print it for yourself on your own 3D printer or at any 3D printing service. I hope you liked this video, which explained to you how you can track different BLE beacons in and around your house, how you can attach those to the objects, to your belongings that you would like to track in and around the house in different areas. And now you can create any automation in Home Assistant you could think of. For example, in the evening, if there is an object still outside of the house or not in the garage, you could automatically send a push notification and a voice notification via your smart speaker, so that you will be informed that you need to go outside and collect those toys or objects from outside. And I think this is super helpful. And yeah, if you like this video, then please also follow my channel for my upcoming videos, and please also comment if you have any ideas about this, or if you have any questions. I'm really happy to discuss this with you. Thank you very much. See you next time.